This is Robert Bell from the World Teleport Association, welcoming you to our webinar for this month, New Antennas and New Opportunities. If you're not familiar with WTA, we are a nonprofit association of the satellite business. We've been around since 1985. And our purpose in this industry is to advocate for the interests of the commercial teleport operators who are so essential to connecting the digital skyway to the digital highway. And yet somehow very often are not as noticed as well in this business as, shall we say, the satellite operators and some of the preeminent technology companies. So we're here to advocate for their interests, make sure that they get known and that their businesses can develop in a very healthy fashion. We're also, though, on the flip side of that, working to promote excellence in their operations, in technology and in business practices, because the more powerful they are as competitors, the more successful the entire industry will be. And we're here to talk about the subject of a report, New Antennas, New Opportunities, which is going to be published before the end of this day. It's about the impact of flat panel antennas on the teleport industry and the larger industry from around it. So after this brief introduction, I'm going to offer you some key insights from that report. And we'll then move into a panel discussion and do some Q&A. I did some research for this report and enjoyed finding out that our satellite antenna technology has been around since 1888, which is a very long time ago. And of course, it was invented by the German physicist Heinrich Hertz when he built the world's first parabolic reflector. So it's been a long time since then, and yet that technology has been with us relatively unchanged, at least in the broadest ways, for all of those years. We're now in an inflection point where we're developing new technologies, and the questions then become, how do they perform? What do they cost? What's their roadmap for future development? And what's going to be the impact on the satellite business as a whole, and in particular, what do teleport operators need to know so they can either take advantage of this or deal with the technology in some other way. Our research reports and our webinars are made possible by the financial support of some leading companies, very well recognized, from Eutelsat, Intelsat, to Kratos, Liquid Telecom, and SES. They are industry leaders of WTA, and we're just very grateful for their support, and quite frankly, couldn't be doing this sort of work without it. So takeaways from this report, which will be published, as I said, before the close of business today. We're looking at a technology inflection point with vast potential and yet a long road still ahead of it to travel. That is because, of course, parabolics are an extremely mature technology with decades of development behind them. The flat panel antennas, or FPAs, are in the early stages of innovation, exploiting new materials and new processes. And like any process of innovation, it's long, it's complicated, it has lots of what look like failures along the road, then you find solutions to, and they sometimes turn into great opportunities for advancement. So it's watch this space and keep watching it, because though some of these antennas are commercial already, there's going to be a great deal more happening in it. Price and performance are definitely a work in progress. Some antennas have been out in the market that have not received good reviews from the people who try to use them. But innovation continues, and that technology does keep improving, whether it's from a commercial company with antennas already in the market or from R&D-based companies that are going to be perfecting their technology over the years. One of the interesting things about this is that the non-geostationary or NGSO constellations that are, of course, are going from concept very rapidly into reality right now, really will depend almost entirely for their success on the success of flat panel antennas. They're the only technology that's going to be able to deal with the thousands of changes per hour that will be required to manage to handle communications from a big constellation and to handle multiple beams where required. But interestingly enough, our respondents for this report felt that FPAs, however, their success does not depend entirely on LEO markets. They're already in use today in very specific applications, and those will expand as that technology improves. And finally, what's the potential for these antennas to ultimately penetrate and cannibalize the established parabolic markets? I've always remembered a conversation I had with, this goes back years, when FPAs were just starting to come out, and he said, well, that's it, just in a few years, you're going to just basically have roof tiles in your home, and that's going to make you a teleport. Well, it turns out to be a little harder than that. And of course, we're talking about The Innovator's Dilemma, the famous book by now deceased Harvard professor Clayton Christensen, who studied disk drive technology and was able to show that there's this thing that nobody had ever noticed before, which is that innovators will develop a new iteration of a technology and find a new niche to apply it to. So in his case, it was all about disk drives shrinking in size from 8 inches to 5¼ inches to 3½ inches. And at each step in that along that road, the innovators ended up cannibalizing, innovating up into the market share of the companies with the established technologies very, very successfully, as their gadgets got cheaper, faster, and better than the established ones. So there's always that opportunity to innovate up into a market. And the question is, will that happen? Well, very, very hard to tell at this point. Some mixed views, but the one view that was consistent across all of our respondents was that the parabolic antenna is going to be here with us for a very long time. It has not only a great established track record and a large installed base, but it's suitable for applications that nothing else is, and probably will remain that way for a very long time. And ultimately, FPAs, as far as our respondents were concerned, are going to end up being, they think, a complementary product rather than anything else. It's going to be ideal for specific applications, and teleport operators are going to need to know how to work with it in order to establish what currently might be a VSAT-based remote terminal is now going to become an FPA-based remote terminal. And so that's going to need to become part of their toolkit. So we've heard enough from me. I edited a report written based upon expert commentary, but that does not make me an expert. Instead, I'm glad to welcome 2 people who do know specifically what they're talking about. One of them is Dr. Leslie Klein, who's president and CEO of CCOM Satellite Systems, which has a very successful mobile VSAT and terminal company that is beginning to move into this particular world. And also José Torres, who is the global sales director for Integrasys in SA in Spain. He's based in the United States. We're glad to have him with us. Integrasys is a company that is so deep into the issues around satellite spectrum that they end up running into every single part of this industry. And so José brings a broad experience to this. So gentlemen, welcome to our program.
Thank you for the intro, Robert.
Okay, and José? Okay, so into our discussion. This is sort of an easy question, I guess. Maybe it's one that many people would already know, but I think it's a good baseline. What is the opportunity that is driving FPA investment? And I'm going to ask you first, Leslie, because your company actually has obtained investment dollars to help you move into this.
Well, we have, thank you, Robert. We have been in the satellite communication business for 23 years. The company is publicly traded. It is a successful company in terms that we have no debt. We have never borrowed money. The company went public in 2000 and raised about $5 million. And since then, we have accumulated over $22 million in working capital, never borrowed money from anyone. And we have developed a large number of communication on the pause antennas that we are selling in 106 countries through about 500 distributors. When we about 5 years ago, we have approached the University of Waterloo, and we asked them if they would be able to develop a phased array antenna for CCOM that could ultimately replace some of the on-the-pause parabolic antennas that we use today in terms of size, weight, and performance. And we specifically zeroed in on Ka band because we felt that would be a very difficult antenna to design. And if a Ka band antenna could be designed in a phased array form, then they would be able to probably move it down to Ku relatively easily. Plus the fact that there was a lot of Ka activity at the time, and many of the satellite operators were moving to Ka, and as it turned out, a lot of the LEO operators are also moving to Ka. So a phased array antenna was a very good option for us to slowly get into the business and make it possible to replace our parabolic communication on the pause antennas, hopefully with a phased array antenna that will provide access to LEO satellites, and also make it possible to move and deliver broadband while moving, so you don't have to be on the pause, and have it done with a very neat, low profile, low cost, and relatively light reflector, not reflector, but a phased array antenna that would ultimately replace the parabolic antenna. So we went around it in a way that we approached the government of Canada, and we received $6 million funding, of which CCOM paid $3 million, and the government paid $3 million, and that funding has been given to the University of Waterloo, where there's about 12 to 15 PhDs and postdocs working on this project for us over the last 4 to 5 years. And we have hired four of the developers already. They're on our payroll, and the others are still doing their PhD and postdoc work as a result of this development. So it's we were, I think, lucky in a sense that we anticipated that this will be a very hot project coming up in a number of years, and we are about at the stage where we are going to be testing this antenna over a LEO satellite, and it seems to be working in a lab as a 1,000 element array, and we look forward to developing this further and making progress with this antenna.
Well, thank you. And Leslie is a proud graduate of the University of Waterloo, as are 3 of his children. So it's quite an institution, listeners, if you don't know about it, in terms of their ability to do research and development in a totally commercial framework. Founded by 2 business executives who got tired of the fact that universities were not training people to actually come and work. So it's a very fine institution. And Leslie, thank you. You did something that I forgot to ask you to do, which was to tell us a little bit about yourself and the company. So I'm going to start there with José. José, would you just tell us a little bit about yourself and Integrasys?
Yes, Robert. Thank you. Happy to be here. Yes, I'm José Torres. I'm the Global Sales Director with Integrasys. As you touched a little bit on the introduction, Integrasys, you know, we make software applications that pretty much, you know, work with the whole ecosystem, the satellite ecosystem. We get involved in the different, you know, applications, products, and particularly on antennas. We're getting heavily involved developing new features. You know, we understand that the technology is changing, that the telecom landscape is changing now. We see a lot of the new projects on the non-GSO satellites, particularly MEOs, LEOs, and we see the future there, how the demand of new antennas, flat panel antennas, and that's where we come into the play, because we try to complement what the antenna manufacturers like CCOM are doing with this investment and creating the new antennas and new technologies, how we could, you know, complement what they're doing with our system. You know, we get involved not only in the carrier monitoring, but we get involved in, you know, the commissioning of the VSAT, how the antenna it gets pointed, and how you do run the commissioning of the antenna in an easy way and in an automated way. So that's where we pretty much, you know, getting these new applications, and we are getting very excited the success of these new satellites. We see the demand, particularly these days when everything is done remotely. A lot of the problems that, you know, you cannot travel as, you know, the way you used to travel, you know, anywhere, anytime. Now it's not the same. So you try to do everything remote. So that's where we come into the play and help with these new applications and new systems, and which I mean, for antennas, it's a great complement.
Absolutely. It's about time that all of our technology got smarter. So, so what you're saying is really, I mean, it's really the drive of LEO. And when somebody writes the adventure story of the low Earth orbit constellations, this is going to be quite a year, right? From bankruptcies to Starlink quietly throwing up 60 satellites at a time until now they're over 500, and just, you know, it's been an amazing story, and I think it's the key driver of all of this. But even before these constellations are in orbit, or at least commercially in orbit, those flat panel antennas are already on the market. So, I mean, Jose, what are some of the applications where they're already getting adoption, even though the technology is not mature?
Oh yeah, we've been working with the standard parabolics. I mean, that's what is out there, and then we work a lot with the fixed antennas, which pretty much, you know, they're standalone. They don't move. We work a lot with we've been working for, you know, a long time supporting those applications on those antennas. So right now with our systems, we have a product called Sat Motion, which is well known in the industry, and we support different technologies, VSAT technologies, and work with different type of antennas. The majority right now are, you know, parabolic fixed antennas.
Well, yeah.
But we seen now the move from fixed to mobile. A lot of the mobility, even if it's land, there's a lot of requests for mobility where these antennas are fixed, but they want to move. They're moving. You know, comes on the bus. We work a lot with those antennas that you know, you move, you repoint, and then, you know, there we restart the process of commissioning and making sure that you're pointing to the right satellite. And so yeah, we've been working a lot on the geo. You know, we know, everybody knows. So and we have other systems, like we monitor that you know, these antennas are not creating any interference.
Well, that's a whole issue that is barely been scratched in terms of the flat panels. But I mean, the early adoption seems to be in mobility, as you just said, right? So it's places where that form factor works best. In fact, there's a demand for that form factor, but also the military applications. I mean, Leslie, what are you seeing in terms of the very early adoption of the existing flat panels on the market?
Well, what I'm seeing is something that's happening through commercial chips, MMICs, that are being developed by a number of companies in the Ku and the Ka band frequency ranges. And CCOM is developing their own MMICs to actually leapfrog the cost and the power issues that are major issues with the flat panel antennas. And in order to actually, for the military, obviously, the money is no object. So you can design a flat panel antenna using off-the-shelf chips that will cost tens of thousands, if not hundreds of thousands, multiple hundreds of thousands of dollars, because the chip cost for the MMICs that are used in the flat panel antennas, like the way we use them, are extremely high. So when you have 1,000 ICs on a board, and each IC is $30 or $40 from a vendor, you're talking about $30,000 to $40,000 for a 1,000 element just a board. So that is certainly not a commercially viable product, but for the military, that would probably be a good deal. And I've seen recently, an announcement by Bell. I think it was. Trying to remember the company that.
I think it was Ball Aerospace, wasn't it?
Yeah, Ball Aerospace that delivered a product for the military. Yes, I'm sure it was probably $500,000, $600,000, $700,000 antenna, and that's doable. It certainly is doable, but how many of those will you sell? So the idea here is to have an MMIC or a chip that does the phase shifting on the board, that is in the dollar range, $2, $3, not $30. And this is what CCOM is striving for, is to develop this chip. We have already developed the first and second generation of this chip, and hopefully we will be able to go further and develop a third generation sometimes next year that will give us both the cost capability, because we are going to build it ourselves. And if you have a 1,000 element antenna that that has 1,000 chips on it, so if you buy 100 antennas, the chip cost hopefully will go down dramatically, because you are now into millions of chips. And similar to ICs used on computers, and the volume will dictate the the cost. So the larger the volume, the lower the cost. And I believe that it will happen. It will take some time, but for now, for CCOM, we would be very happy if a $25,000 parabolic on the pause antenna could be replaced with a K-band phased array antenna for the same price and give them mobility and ability to track multiple LEO satellites. So our objective is to move in that direction. But today, I don't think there's anybody out there that has a product that's commercially viable, that has a product that's even technically viable, and it will take a while before we get there.
Well, I'm sure some of them would disagree with you, but that's the privilege of each of you. But price and performance are the key factors. So you're taking a chip-based approach. I know that SatixFy is doing the same thing. It's been interesting to me that two of the competitors in the business, Kymeta and Alcon, are both taking a production line approach by developing their technologies so that they can actually the antennas can be produced on the same kind of production lines that turn out televisions and monitors and so forth. So there's a lot of different approaches, but I mean, so where are we? You said that you don't think there's anybody who's out there who's viable. What's viability going to?
Yeah, by viable, I mean that you have a product that's commercially accepted, that can be manufactured in large volumes, and it performs close to, if not exactly, the way a parabolic antenna does. So if you don't meet all those requirements, you are really not competing with a parabolic antenna.
Exactly. José, so again, you're seeing, these are issues of price and performance. As you look at this and think about how your company needs to adapt to a potential success of FPAs in a commercial sense, how are you thinking about accessing that opportunity should it come?
Yeah, I think what is happening now, we see an increased demand on the government side. A lot of the military applications, we see that they're willing to pay the price. They're willing to invest on maybe more expensive antenna, but getting all the benefits of that. So we see an increase on these new flat panel antennas. They're willing to jump and hey, well, I want to invest and develop an antenna that will do a better job for me. We talk about comps on the pause, how the government is looking the real comps of the move, which you don't need to pretty much stop and repoint. You want to do really what is the comps on the move, and I think that's what creating the demand and the early adopters of these technologies. So we see that on the aviation market, where obviously the form factor plays an important role. You need an antenna that can fit in the airplane, and that's where these flat panel antennas is like perfect, right? It's a perfect scenario. Now, obviously, there are a lot of technicalities that maybe Leslie know better than I do. All the challenges of getting the bandwidth that you require and be able to don't have any issues with the look angles and things like that. But we see that on like I said, a military, government, aviation, some of the enterprise applications that are out there. We see companies like Kymeta that is already out there selling their antennas, flat panel antennas, and we see that there's some demand on that side of the industry where that's the beginning, and hopefully the pricing will go down, that's one of the major issues at this moment, how you can compete with the pricing of a parabolic, right? And that's where we help with applications with the SatMotion application. Like for example, we have a product called SatMotion API, which is pretty much we talk with the brain of the antenna, which is the antenna control unit, the ACU, and we make sure the antenna, even that the manufacturers already repoint antennas and are able to do it automatically, we help to do it in an accurate way, like be able to pretty much mitigate the cross pole as much as possible, be able to not create interference like I mentioned before. So our systems allow you to do that, to get an accurate pointing, which is
So I'm sorry, I just want to ask, I just can't resist asking the question. So, well, actually, I'm going to save this question until later about FPAs, about the future of FPAs. But yeah, it's software is going to end up being, of course, essential to all of these kind of products. Actually, I want to switch back to Leslie just for a second, because Leslie, you've been through this interesting set of announcements. You announced back in May that you were going to build a phased array antenna in partnership with the University of Waterloo. In August, you got your funding from the Canadian Space Agency. You most recently joined an international phased array development consortium, which really got my attention. So, what is that consortium? How does that help your project step forward?
Well, it's actually going to utilize our 4x4 element antenna as part of the front end of this next generation 5G millimeter wave technology in the V-band frequency. So we are looking down 3 years down the road, and you know, if you look at some of the LEO constellation operators, they have already all requested FCC approval for V-band. And this consortium of the semiconductor manufacturers in the Netherlands and the US and Canada, and the three universities have received funding both from the Penta program in Europe and from the Canadian Space Agency and the Eureka program, the Eureka Penta program in Europe, to develop this next generation V-band very high frequency technology for 5G. So essentially, today we don't really have 5G. It's more like 4.5G. And I think the real 5G and 5G plus is still something that has to be demonstrated. And I think V-band will play a very high role in delivering very high performance over satellite and over cellular. So our antenna is going to be part of this consortium, and there will be a front end built for it by one of the semiconductor manufacturer companies, and a back end for it. And ultimately, we hope to see this to be used in cellular handsets, and also in a cellular communication, in HAPS and other applications where you will be able to get 10 to 100 times more bandwidth on your phone than you can get today. So this consortium is going to be designing this new technology, and we received funding for it. So CCOM is really only supplying what we already have, and also we will be adding some testing of this product, this new product, when it becomes available, and we'll be as part of this consortium, we'll be able to generate some revenues with this V-band 5G plus type of solution.
There you go. You brought it back to the fact that that's what one of the things we're here to do, is to make some money.
That's right.
Because I've always been fascinated by the arguments going on right now around that whole thing. It's like Peter Drucker years ago, solved the problem for us. He says earning a profit is not like a goal. It's your minimum. It's your minimum condition to survive.
Absolutely. And and we expect that with these fundings we can generate it on our own, and also from these grants that are non-repayable, we will get benefits of developing the next generation technology utilizing the existing phased array antenna that we have already developed, and of course, as you mentioned before, the type of applications that this type of a solution could apply to, from IoT to many others, will be phenomenal if you have a product that is priced right and performs.
There was a speculative question we asked our interviewees for the report, which was about exactly what you just mentioned, which is the potential intersection of 5G and this satellite technology. And the thought was that the opportunities in 5G are going to act as an incentive and a driver of innovation in flat panel antennas that will also benefit the satellite industry. So it sounds to me like you're a believer in that proposition.
Absolutely. I think this HEFPA program, high efficiency and flexible phased array program, shows that there is a crossover between satellite and cellular. And I think 5G, because of its nature, it's very much the same as the Ka band in terms of frequency range. It will apply to definitely to both satellite and cellular. And having a V-band solution that will also work for both satellite and cellular in a couple of years is a huge opportunity to to expand the technology, to combine both satellite and cellular together and have a product from it that will work in either environment.
Interesting, interesting. Jose, let's come back to you. Integrasys has, as you've mentioned, has a very broad range of products which are entirely about RF spectrum in one way, shape, or form. Everything you do is software about spectrum. Have you given thought to this interesting question, which is how on Earth or in space we're going to manage, in a world of thousands of LEO satellites and potentially millions of these flat panel antennas or any other kind of antenna, all operating at the same time, trying to deliver service to us? It's a huge issue, and yet I don't know. I know people are obviously working on it from a frequency coordination standpoint, but when you get down to the antennas on the ground, it's going to be quite a problem. Yeah,
indeed. Well, we're looking forward to getting to that.
I bet you are.
Yeah, that's a good question, and I think one of the things that we're doing with our technology, with our software development, is be able to support not only 10 VSATs or 10 antennas, 15, 20. We want to support hundreds or thousands, or in this case, millions if we get to that point. But one of the things is we are our technology. It's unlimited, meaning that you could be adding antennas, VSATs into your system, your platform, without getting any issues on performance. So that's one of the things that we take always in consideration, because we work right now with networks that some of these networks could be small. We can have a 100-site network, which the system will work perfectly. But in some cases, we have these government networks where they have thousands of VSATs, and it performs the same. It doesn't change the performance with using our systems. So we don't see any issues on that regards. I mean, obviously the challenge will be get to that point, right? I mean, but I don't see any limitations on the technology at this point.
Well, let's hope you're right. I mean, I know you're right, because we're very good at conceiving problems and figuring out solutions to them in time to keep them from slowing us down. So looking into the future, because that's really where we've sort of ended up, what's your take, and I guess I'll start with you, Leslie, your take on this potential future in which the flat panel antenna basically causes the slow sunset of our faithful parabolics that have been serving us for so long? I
would say that will take a while before parabolic antennas are replaced with flat panel electronically steered antennas. You have to be able to come down to the price range of $200-some or less, sometimes even $50 for a very low end parabolic antenna that can be punched out, from steel or aluminum or SMC, made from SMC, and I can't see anytime soon that we will be able to have a very complex printed circuit board type or any other type antenna that will provide the same performance or even close to the performance, have the same look angle capabilities, and have the same durability at the same price. So I think it will take a long time. I would say that if we compare the cellular phone progress from the day when it came out and it was the size of a suitcase with its own separate power supply, etc., and to the day where you have something that fits into your pocket, I mean, it probably will take something very close to the same time frame.
That makes entire sense to me. Yeah, it's going to be a while, but I also think there'll be lots of unexpected things to happen along the way. My final question for both of you is based upon your experience in the market, and you both obviously you've got a great deal of that. What specifically do you think in the next 5 years, let's just say, pick that number, do teleport operators, the people running, fixed ground segment infrastructure, and in many cases running quite large networks that are currently supplied by VSAT, as well as military applications, as well as aeronautical applications and so on, what do they need to understand about the future of FPAs, and what role can they expect those new antennas to play in service provision for their customers? And Jose, let's start with you.
Yeah, I don't think the flat panel antennas will be replacing all the parabolics. I mean, I think for the operator's perspective, they have huge antennas, like 9 meters, or those big antennas, which they're going to continue there. I mean, they're just going to continue operating the way they work with the GEO satellites, and I think the flat panel antennas will pretty much complement, talking about complement the technologies to be able to, okay, well, now it's not going to replace what we already have, but it's going to add these new technologies, and then that's going to help them to maybe get into new markets. And so I think that's what's going to happen. The LEO MEO markets are going to generate the demand for these flat panel antennas, and so you're going to have the LEO MEO applications which will demand these flat panel antennas, and then you're going to continue having the fixed GEO, which they're going to continue working with what they have, right?
Yes, they will. We always use the installed base. Leslie, what do you? I mean, you're obviously selling a lot of portable VSAT antennas to a lot of people. What do you think the companies that use those to build networks for their customers need to know about flat panels, in the next 5 years?
Well, interestingly enough, we have done a study almost a year ago for a company that wanted us to replace 3, tracking antennas for LEO, MEO type of earth stations, because they're obviously very large, very expensive to operate. You need multiples of them to track a LEO or a MEO because they have to move, and then they have to hand over from one to the other. And we have estimated that the phased array, multiple phased array antennas, which our design allows to combine 4,000 element antennas into a large panel, would ultimately be possible to replace these huge mechanical antennas. We did a 3.5 meter analysis of a tracking antenna using multiple 4,000 element boards, and we know that is something that will be doable. And because of the cost of these 3 antennas that you could probably replace with 2 large phased array antennas instead of 3, 1 spare and 1 working, you would be able to save a lot of money. And of course, they are not mechanical, so the operating cost of these antennas would be significantly less. And so I believe that it's going to be possible to have those earth station antennas using phased array antennas fairly shortly, and they will be able to provide the customer the ability to track and not using a mechanical antenna. So that will happen for sure.
Interesting. That's interesting. So the running costs of those, and it's interesting to say, the running costs of those antennas in terms of maintenance, operation, power, and so forth are significant enough so that even though it's a nice installed base and you already bought them once, it still becomes worthwhile?
Yes, it will be, because ultimately I think the performance and the overall yearly cost, plus the new installations where you have to buy 3 of these antennas rather than 2 phased array antennas, and the price difference will be significant, that it will make a lot of sense for those operators to consider either replacing or buying new ones to replace at the end of life or whatever it is, because the ongoing operating cost of those, obviously both in terms of mechanical use and reliability and all of that will make a difference. So will be interesting to see, but we've done some analysis, and cost-wise, I think it is possible that those phased array antennas will be utilizable to replace those large mechanical tracking antennas.
Interesting. So tracking is next after mobility. Tracking is next on the list. And by the way, this conversation is focused on price and cost and so forth very appropriately. One of our attendees has noted that, of course, in emerging countries, and particularly where the price sensitivity is naturally high, that price is going to have to really come down. This person estimated into the $400 to $500 US range.
Right.
That's a long way to go, right? But by that time, we're looking at the future of the connected car and a whole bunch of other exciting things that have been talked about since since this whole revolution happened.
Just to mention one thing that CCOM is in parallel doing is we have developed and patented a novel dielectric-based phase shifter, and this phase shifter, instead of costing $30 or $40 like per IC, will cost 3 or 4 cents, hopefully. And it's a passive antenna, so it doesn't have the same exact characteristics as an active antenna. But cost-wise, we hope that if this product, which we already built a 4x4 design around it, and we patented the design, it's actually a coplanar waveguide combined with ceramic high resistivity silicone, which makes it possible to actually shift the phase with a 9-volt battery. So you can have an extremely low power requirement for it, and if you can build multiple elements of these into an antenna, then you may be able to come up with a $500 or $1,000 phased array antenna. But we are not there today, and we are still in a lab with it, but we have patented the design, and we believe that has a huge potential for reducing the overall cost of a phased array antenna.
Yeah, it's very interesting. It's very interesting. These are the kind of innovations that are going to come sneaking up from all kinds of corners. So I want to thank you, Leslie, and you, Jose, for spending this time with us and sharing your expertise. I've learned something, as I always hope to do from these webinars, and I'm sure our audience has as well.
Thank you very much, Robert, for inviting us, and it was a pleasure talking to everybody here. If there's any questions, obviously we'll be happy to answer them.
Of course. And Jose, thank you.
Well, yeah, thank you very much, Robert. Thank you for the opportunity, and looking forward for these new LEOs, MEOs, and I think that will, generate the demand, and that's always the question. Who's first, the satellite or the ground equipment? Who's coming first?
Well, this time they have to come together. That's the interesting part about this whole thing, right?
Yeah.
Well, we shall see. Coming up, we'll be publishing in October Inside the Top Operators. This is an annual report we do based on a survey of the largest and fastest growing teleport operators of the year, always some interesting stuff in there. Then later in October, we expect to publish how customers' quality of service demands vary by vertical market. This is in our high performance series, which is drawn from the WTA teleport certification program and the data that it generates. So this is Robert Bell from World Teleport Association. Thanking you for joining us, and we look forward to having you with us on our next webinar. Be safe.